Check. Hello. Testing. Hello. Testing. Check. Hello. Check. Hello. Testing. Hello. Testing. Testing. Check. Hello. Audio check.
Hello.
Hello, sir. Is it audible?
Just a
Sir,
minute.
can you hear me, sir? Sir,
Yeah, I could hear you with very low voice.
okay.
How about me? Can you hear me?
Yes, sir. Is it okay now, sir?
I can hear, but it's very low for me. Try now.
Sir, we சார் இப்போ கேட்குங்களாங்க சார்? ஹலோ சார்,
Hello.
கேட்குதுங்களா? ஹலோ,
சொல்லுங்க.
இப்போ நல்லா ஆடியோ வருதுங்களாங்க சார்?
ரொம்ப லோவா கேக்குதுங்க.
ஹலோ,
ஹலோ.
இப்போங்க சார்?
ஒரு நிமிஷம்.
மேக்ஸிமம் வச்சுட்டிங்களா? சார், இங்கே
இப்ப செக்
மேக்ஸிமம்
பண்ணுங்க.
ஆடியோ தான் வச்சுருக்குறாங்க. மேக்ஸிமம் ஆடியோ தான் இங்கே வச்சுருக்குறாங்க சார். அங்கே உங்களுதில் மேக்ஸிமம் ஆடியோ வச்சுருங்க சார். ஹலோ சார், கேட்குதுங்களா?
இல்லைங்க, ரொம்ப லோவா தான் கேக்குது.
சார், நாங்கள் செக் பண்ணிடுறோங்க சார்.
ஓகே.
சார் இப்போ கேட்குதுங்களா? ஹலோ.
கேட்கலீங்களே. அதான் லோவாக தான் கேட்குது.
check.
ஹலோ சார், இப்போ ஓரளவு கேட்குங்களா?
ஹலோ.
ஓரளவு கேட்குங்களாங்க சார்?
இப்போ கம்மி, ஓரளவுக்கு தான் கேட்குது.
சரிங்க
லோவாக
சார்.
தான் கேட்குது.
ஆக்சுவலாக நான் இன்ட்ரோ கொடுத்ததுக்கப்புறம் இப்போ நீங்கள் தான் ஃபுல்லாக செஷன் எடுத்து போகிறீங்க சார். அதனால் எங்களுக்கு நல்லா ஃபுல்லாக கேட்குதுங்க. இன்கேஸ் அப்படி ஏதாச்சும் ஆடிபிள் இல்லைன்னா வேணால் நாங்கள் சொல்கிறோங்க சார். நாங்கள் அப்புறம் மறுபடியும் ஏதாச்சும் இன்ட்ராக்ஷன் பண்ணுறப்போ மறுபடியும் பேசிக்கலாங்க சார். ஓகேங்களா?
இப்போ சுத்தமாக கேட்கலங்க. ஏதோ ரொம்ப லோவாக கேட்குது திரும்பியும். சரி, நீங்கள் ஸ்டார்ட் பண்ணுங்க, அப்புறம் எனக்கு இது டேக் ஓவர் பண்ணுங்க.
ஓகே சார்.
Did you start?
Okay, sir. We can start the session. Good morning to the resource person, Sarvesh Ramuj sir, and all the faculty members from various departments to this FTP session regarding GenAl ecosystem, which has been organized by GASC Alumni Association. Today, our resource person, Sarvesh Ramurthy, is an alumni of our college. He is a principal engineer, general manager level at Commonwealth Bank of Australia with 21 years of experience leading large-scale enterprise cloud migrations and AI solution delivery. He has also worked with research-driven organizations where he created groundbreaking discoveries and high-impact technical artifacts. An official AWS trainer, he holds 6 AWS certifications and 4 Azure certifications and is a TOGAF certificate enterprise architect practitioner. He is a Brighter Tech Awards recipient, receiving the award from the Deputy Governor of the Reserve Bank of Australia and the Prime Minister of Australia, and an Ultimate State Awards recipient presented by the Governor General of Australia. Now I hand over the session to our resource person. Sir, you can start the session, sir.
Okay. Thank you, everyone. First of all, thanks for giving me this opportunity. I'm pretty glad that I passed out of BSc CS 1998 to 2001. It was a golden era at the college, and one of the most memorable time I can't forget in my lifetime. Uh, so let me share my screen. Can you all see my screen?
Yes, sir. The screen is visible.
Okay. So before we go into the topic, just another quick round of introduction. So I'm the principal engineer with, this is at the general manager level, the executive level at Commonwealth Bank of Australia. You must have heard of Commonwealth Bank of Australia, CBA. They are the seventh largest bank in the world. And on top of that, I have these certifications already Arul would have mentioned. On top of it, I am an architecture review board member for the whole of Australia. Also an AI research fellow member, and I'm an official AWS trainer. Uh, and on top of it, I also have I got the Ultimate State Awards and the Brighter Tech Awards from the Prime Minister and the Governor General. Uh, so why I want to share this topic today? It's basically AI and Gen AI, right? If you might have seen in the last 3 years or 4 years, there's a lot of buzzing things going on with AI. AI is replacing developers. AI is replacing a lot of jobs in not only in as developers, also in other industry, and a lot of transformations going on, new models. Um, the so basically, I want to just give an idea like what's going on in this ecosystem, and a lot of news and insights regarding this. Technically speaking, AI is not replacing the jobs, it's just transforming the industry into a different place, different level. So what happened is like imagine you were before the industrial era, right? When industries and machines were produced, people thought lot of people will lose jobs because machine basically replaces people's human effort, right? But that was not the case. Actually, even after bringing and inventing machines, transformed into a complete different industry, and a lot of people move into the manufacturing industry. So similarly, there's a lot of buzz going on, and hype saying that people will lose jobs and uh, it'll replace everyone. That's not the case. So the way computer and IT industry is actually at the moment now, and how it's getting transformed, it's going in a different direction. So what we would require is basically here afterwards we don't need to know any programming language or a particular operating system or anything. All we need is to understand how AI and Gen AI works, and we create apps, and we the whole idea is that we are moving towards in a different way where we interact with these systems and create products and applications. So all those resources who are actually learning about these systems and adapting to the generative AI ecosystem, they will be employed. So how it is functioning, how does it work, where did it start? I'll go through in detail. So this is like I lost my original presentation, so I created this in a matter of 5 minutes. If you believe, I'll just show how I created as well through the Gen AI systems. So any questions so far before I go?
No, sir. You can continue, sir. You can continue, sir.
Right. Okay. So coming to this topic, before we delve into Gen AI, for the sake of the audience, I want to actually uh, let me go through some of the key concepts of AI. Only then you'll understand what actually Gen AI is all about. Otherwise, it will be a bit disconnected. So what is an AI? It's very simple. Computers can't think, right? Every time if you need to do some operation in a computer, or you want to do a particular task, you tell computer. So how do you tell computer? Is basically you write code or programs. You say, this is my flow, this is my decision, these are my inputs, these are my flows, and then you execute it and provide the input. It actually executes the code and then produces the output. So it can't think anything beyond how and what you have programmed. But artificial intelligence is basically making computer think like humans, like humans. So how we think. So what do we do? What are our capabilities, right? Basic capabilities. We have problem solving skills. We can do very good decision making. We can understand new things based on what we have learned in the past. So that's what is artificial intelligence about. Can we mimic all the capabilities of human, how we learn, how we adapt, how we make decisions into computer? So that's what AI in a broad level is about. But is AI new? We are talking a lot about what's happening in the few months or years, right? But AI is not new. It has been there for a while. So if you see this picture, AI started long back in 1950s itself. So where Alan Turing performed his first Turing test, and then followed by 1980, there were a lot of expert systems. In 2012, there was introduction of deep learning, and 2023, the era of Gen AI, which where we had, as you might already be knowing, and many of you might be using, GPT-4, Chat GPT, and a lot of other tools, Perplexity, and all the things, right? The same, if you see on the other side of the plane, you will see in 1956, there was a Dartmouth conference, and in 1997, there was a first AI program which actually bet the grand champion Gary Kasparov. And 2020, the invention of GPT-3, and 2025, now we have multimodal and agentic AI. Now, how do we visualize this, right? So this is the history. Now, if you see this picture on a high level, I'll try to explain as simple as possible so that it reaches all the audience. So AI is an overarching terminology. It's a very general concept, right? So it involves everything. So the subset of AI is machine learning, and the subset of machine learning is deep learning, and the subset of deep learning is generative AI. So AI is how can you actually induce intelligence to the computer? You can do it many ways, right? One example is rule based. So you say every single permutations and combinations, you can define them as rules, and then tell the computer that if you execute all these rules and try to predict something. So an example is in 1960s and 70s, there were a lot of rare diseases. So what one of the scientists did is that he collected the medical records of all the patients who were diagnosed and unfortunately died. Uh, he and every case was different, right? Because every human is different, they have different medical conditions and all these things. So he collected all this data to actually diagnose a certain disease, that if you have certain symptoms, you fall, most likely you'll be a prey of that disease. So the more the data he collected, he formulated all these rules so that tomorrow a new patient comes in and diagnose. Let's say they are doing medical diagnosis. Finally, they find out that this patient either is actually succumbed to that disease, or most likely is about to get the disease. So that was one type of artificial intelligence. And then the evolution, a lot of things happened in evolution, and then things got changed. Machine learning came into picture. So what is machine learning? Rather than rules, right? Because rules are, let's imagine if you want to make a decision based out of rules, every single permutation and combination is so complex, it's very hard for anyone to learn just by rules. So machine learning came into picture so that the machine learns through data. So what you do is you collect data, trans clean it, transform it in a representable format, and the machine learns from the data. I'll explain in detail what it is. So there are different ways to learn. And depending on the data, when it sees a new data, it will predict or classify or make a decision, right? So for example, I can say, let's say a machine has to identify a fruit. So what they used to do is they used to collect uh, a lot of publicly available data of different type of fruits and their image, and then train the model, right? So machine learning basically works on a model. The terminology is called model. So we scientists collect huge volume of data, train the model with the data and the algorithm. And the algorithm will change depending on what is the outcome, right? What decision you want to make or what is the outcome, basically. Uh, so that's how the whole machine learning is trained. So some of the examples are like, for example, Netflix recommendation, fraud detection, and all these things. So deep learning is a subset of machine learning. So what deep learning is about? So machine learning, even though it could learn with data and make decisions or predict something, it was very primitive, right? So deep learning, in case, for example, in let's say you want to do a facial recognition or you want to do a complex tasks with audio or video, and when the data itself is very complex, it's not just plain rule-based data or very simple data. That's where deep learning came into picture, where you learn everything with the data that doesn't change, but then you have multiple neurons, like how our brains work, right? We have multiple neurons interconnected to each other. Similar way, the how the system or the machine learns is that there are a lot of neurons, everything are interconnected, and you have multiple layers, a very complex system. Uh, and based on that, it actually predicts or makes a decision, right? So how in order to connect all these new nodes, what I'm talking about, and multi-layers, you need a lot of GPU, graphical processing unit. You might have heard this word like everywhere. AI burns a lot of GPU, and GPU consumes a lot of power and money, and that's where this picture comes into. Last, GenAI, which is called generative AI. Examples: ChatGPT, Perplexity, and every other tool which Gemini and all the other tools which you use. It's again a subset of deep learning. The difference is GenAI, again, it's trained on a large model and huge volume of data, but the only difference is it can generate new content. For example, you can say, hey, ChatGPT, create me an image of something, create me a video of whatever you want, or you can ask, create me a PowerPoint material and all those things. That is what Gen AI is about. And there are a lot of tools and concepts in Gen AI, which I'll go through. Any questions so far?
No, sir.
So before I go into Gen AI, there are some fundamental concepts you need to understand how it works behind the scenes, right? So there are foundations basically. For machine learning, you have. So how do you train the computer, right? Basically, so you have data, right? Quality data, and you have algorithms. Now, how do you know which algorithm to apply depending on the data, right? So your use case could be different. For example, your use case could be predicting a weather. So that's a prediction. That's a different use case. Somebody might have a use case saying that analyze a lot of videos and then generate me a recommendation. So that's a different use case. You go to a shopping website like Amazon or any other website, you would have noticed product recommendations, right? So let's say you're buying a product, most likely you will buy an associated or affiliated product, most likely. So every use case is different. So depending on the use case, you choose the data and also train it in a different way, right? So how do you train it, right? You have to know what and how you want to train, right? So you have these type of learnings: supervised, unsupervised, semi-supervised, reinforcement, and semi. I'll not go through everything. I'll just go through some of them. So supervised learning is about labeling the data. Some of the outcomes are classification and regression, and unsupervised learning is basically based out of unlabeled data to find the patterns. And reinforcement learning is basically learning through trial and error. So they call it rewards and penalties, but basically it's trial and error. So one example here you can see, like I was mentioning earlier, supervised learning. You have this input data, and these are labeled, right? So a human or another machine, basically the data scientist uploads different types of images of apple and labels them, these are apples. Now, tomorrow, let's say a camera captures a system, captures an object, right? A picture, whatever, and it wants to identify this particular piece in the image is an apple or not. How it does is it processes the image and compares the learning what it has acquired through the model, through the labeled data, and then it identifies it's an apple, right? So this is completely a new image, not the exact image which the model was trained for, right? So that's how supervised learning works. And what is unsupervised learning? Here, you don't label anything. You don't say this is a banana, this is an apple, or etc. What it does is the machine by itself tries to categorize. So the best example would be, let's say in a shopping site like Flipkart or Amazon, until the customer makes a transaction or they buy some goods, you never know what they're going to buy, right? So once you capture all the data of the transactions, purchase transactions, what it'll do is it'll try to identify the pattern, right? The machine will think, okay, I don't know what is this, but it tries to find the pattern. These look same. These two look very similar, and these look similar. So it says I found three categories. It doesn't say anything. It doesn't know whether it's apple or banana. It just says out of this data, these are these are the groups, and each item inside these groups follows some pattern. Now a human or another machine or another model says, okay, depending on the use case, I would say this is apple, this is peach, and this is banana, something like this, right? So that's how the unsupervised learning works. Now, coming to reinforcement learning, this is very key and very important, and most of the Gen AI works through reinforcement learning, right? So you have input raw data, you don't classify, you don't tell anything, right? You have an environment and you have an machine learning agent. I'll come to agent when we reach that topic. So what you do is, like I mentioned, it's a trial and error, right? Every decision it makes, if it's a wrong decision or a right decision, there can be only two decisions, right? Whether it's a wrong move or a right move. So when it's a right move, you give a reward. When it's a wrong move, you give a penalty, right? So depending on that, it keeps learning. So for the best example would be a maze, right? So you want to go from one end to the other end. Obviously, you have blockages every path you go. So what happens is that every move, it actually the machine calculates based on the move, whether you go left, right, or straight. It calculates the reward or penalty, and based on that, over uh, over a lot of iterations, it learns and then produces the output. So, and then say, for example, to move from here to here, there are two different ways, and these are the outputs. These are the path, basically, something like this. Any questions so far? Shall I continue? Okay. Now,
Sir, can you explain the
I'll go
self-supervised
through some
learning?
of the some more concepts of ML. Now, you have data, you have model, you have algorithm, and you know how you have the methodology to learn, whether it's supervised or unsupervised or reinforcement learning, right? Now, whatever outputs or predictions or classification the AI generated, right here, whatever base it, how do you know whether it's correct or not? Because you have trained, how do you know it achieved its goal? How do you know it's correct or not? So we need a metric to measure whether the AI has generated the correct output based on our objective, right? And that is these are the concepts to actually measure whether your AI or ML model is performing as per your intended behavior, right? So, for example, I can give you a code for overfitting and underfitting, right? So, when you train the AI, you have a training data. So you don't. By the way, what do I mean by training data is there's a difference between raw data and training data. So raw data is everything you collect from the internet and any public sources, right? But that won't make any difference or that won't make any sense when you train the model. So what you need to do is a lot of time, data scientists, what they do is they collect the data, clean, remove the duplicates. They just actually, and sometimes enhance or augment the data and use only quality data to train the model. Why are we doing this? Any guesses? It's basically garbage in, garbage out, right? So if you have uh, low quality data or a garbage data, no matter how good you train the model, you will always get the garbage, right? So or the wrong answer. So similarly, your training data is very important. Now, on the other side, you have evaluation data, right? What is evaluation data? You have a training data, you have a model, and the AI actually predicted through the model some output. Now you have to measure the output, right? You have to know whether it's correct or not. So you have another data similar to training called evaluation data. So you say, for example, 1 plus 1 equal to 2. This is apple, this is orange, etc. Right? So this is all evaluation data. So whatever the output, you compare that with the evaluation data again through an modeling through a AI process, and then decide and measure your performance. Okay, right? Now again, like I said, AI ML, there's no right or wrong answer. There's no 100% correct answer, right? So you can only be as accurate as possible. 100% accuracy is not possible in any system, in any flavor, right? So how do you know? Oh, you have overfitting and underfitting, right? So overfitting is something like, let's say your output performance is performing well on the training data, but not on the evaluation data. Underfitting is basically it doesn't even perform well, even on the training data, which means that your quality of the data is not that great. The best use case and the expectation is your output should be in this line. Basically, it should be neither underfitting, neither overfitting. Any questions before I go to GenAI? Okay. So GenAI, like I mentioned, it's generative AI. So what happens is that rather than a predictive answer, it actually generates content. So for example, let's say I want to create a website. I want to create a text summarization. I want to create a new image. I want to create an audio file. For example, your subtitles, right, where it converts your speech to a language, a text, basically everything. It's everything can be done by generative AI. So generative AI is just a concept. There are plenty of platforms and tools to which achieves generative AI concepts, right? So what it does, generative AI, it actually learns patterns from the data. It also classifies and predicts a lot of things. Some of the examples are which you might be using already in your day-to-day life is ChatGPT, Claude. We use Claude a lot for code generation. So how does it work on a diagram in an illustration for the illustration purpose? As you can see, this is your input. So it's sanitized, it's augmented properly because you need quality data, right? And you have multiple models. I'll come to the model. There are a lot of models. There's like Bedrock, Sonnet, Claude, Anthropic models. I'll come to that. And then you have you distribute the data, and then based on the model, how the model was trained, it generates the output. So, like I was mentioning, the AI or GenAI, they fundamentally work on models, right? So in GenAI, you have two concepts, large language models. You might have heard this terminology, LLMs and foundation models. So what are foundation models? They're basically a large model, which are trained on very broad data, like from public internet and it can typically contain a wide, the diversity of the data is very high, right? So it's pre-trained on massive data sets. And the good thing with this is it can be fine-tuned based on business use case and your individual use case. We also have multi-model model. Basically, what you can do is like, for example, your ChatGPT is one of the example for multi-model model where it can do everything. So you can ask it to generate a text, you can ask it to generate a image, video, whatever you want, right? Now, coming to LLMs, which is the large foundation models. Again, it's fundamentally based on the foundation models. Every single Gen AI tool, what you see now, what you see in the market, Gen AI, Perplexity, Gemini, whichever tools which you are working day to day, is based on LLM behind the scenes, right? So what are LLMs? Is basically you have foundation models for different use case, right? So for example, a text generation foundation model cannot generate a video. A generating foundation model cannot generate a text, right? So every foundation model is specialized on certain things. So uh, the large language models, what it does is it uses the foundation models, orchestrates them. It uses a transformation architecture. And again, these models, like I mentioned, it's trained on massive data and generates the respective output. Now, how does it work? It's basically based on tokens. So when you go to ChatGPT, right? For example, I can show you. When you type something like this, right? Say, so these are tokens. These are input tokens. Right now, this is your output, right? It's basically a dynamic content, right? So it has a particular image, and here it has a lot of text. The content related to the expected content related to my input token. So these are input tokens, right? So you might think each word is a token. That's not the case. How do you know the token? How does it work? Is basically something like this. You just copy paste here in this tool. So it shows you here, sometimes space, comma, they are also, every model has a different mechanism. Sometimes it actually combines relevant words into one token. Sometimes it actually splits certain words into multiple tokens, a single word, and sometimes it's actually combining even spaces and commas. So in this case, if you notice, there are 6 tokens, but actually I have only 5 words, right? So how did it actually split this? For example, if you can see here, this is a token, this is a separate token, right? Over here, all these are separate. That's why you have 6 tokens. Now, what is a context window, right? So this is context window, what I was talking about. This output, what you're seeing here, is the context window in ChatGPT. This one. So when you use a model other than the free version, you are actually charged based on your input token size, whatever your limit is, and the context window, the content generated, basically. So as you can see, here we have a traditional machine learning where we have a different set of with different types of content. This is audio, video, images, etc. And you have specialized model as per the use case and the type of the data, and then you achieve only certain tasks, right? For example, you want to transform an audio, you want to transform a video, you can only do a very specific task. You can't do a broad variety of task. Whereas in your foundation models, the LLMs, you have data of different types with different data sources, basically. And this massive foundation model is built on multiple different type of learnings. So it's basically, it could be a combination of any set of learnings which we discussed earlier. And we have this concept of prompting. So what is prompting is basically this is what is prompting, right? So basically over here, I am asking the AI a question. It understands the question. And generates the output, right? So this is prompting. Depending on the way you actually interact with the system, so you can ask in a different way, like, right? So I could be very generic, I could be very descriptive, I could say don't generate negative content, or my conditions and requirements will be very specific. So I can all mention there are different ways to basically interact with the system. So this way how you actually prompt is called prompt engineering. So there's a big shift and paradigm going on because Gen AI can generate a lot of code for you. All we need is engineers to be best in prompting. So they have to be a bit clever how to actually generate and construct these prompts. So that's where the industry is moving on. This was one of the examples which I showed you in the other website. And tokens not necessarily have to be text. It can be anything, image, audio. You can attach anything and ask it. The prompt engineering, what I was talking about, when you type, right, or when you're actually asking the generative AI system to generate an output. So you can do it in different ways. You can be it very specific, very generic, You can ask a simple question with no examples. So that's called zero shot prompting. Few shot prompting is like you can give it some examples. Hey, I have some reference. I have some example. Consider that, and then generate the response. Right now, we have another concept called RAG in generative AI, which is called retrieval augmented generation. Now, if you notice, every LLM, it's basically pre-trained on a large amount of data, right? Publicly available data or private or whatever is it, right? Now, how does if there are any sensitive information or any proprietary information which is not publicly available, your model does not have any idea about that, right? So, for example, in our bank, we have customer data, credit card information. Obviously, we won't publish it in a public website or anywhere else, right? Because it's a security issue. So this is only available inside our environment, and it's not exposed anywhere. And this is very specific, and this is only specific to bank. This is not a generalized data. So how now? If I want to tell my AI LLM Gen AI model, uh, you should make some decision partially from the public information, but also look at the internal proprietary information and make a decision, right? So this internal proprietary information, it has no clue because it was not trained on that data, right? It was only trained on the publicly available data. So what we do is any information that can be searchable, even though it is internal and proprietary, we create a concept called knowledge base, right? So through that knowledge base, we have this concept of RAG. We actually hook into the GenAI system and say, when you actually do that searching and when we prompted and it's doing the processing, right, to generate the output, any relevant information where you are not pre-trained for, look at this knowledge base and then generate the output. So it's basically like a dictionary. You're telling, hey, I have a predefined dictionary where all the data is organized properly because this is my company employee information, right? Or my customer information, which I already have it organized. So I could use, I would expose it as RAG and then tell the LLM to actually use this information and make an informed decision. So that is RAG. Now, what is MCP? This is very important again. MCP is basically Model Context Protocol, right? Now, two ways you can you can tell the Gen AI. The first way is basically I have a predefined information organized in a certain format, right? Don't worry about the technical things, the vector databases and all these things. That's how it behind the scenes it works. Let's say if you want to understand, you ask ChatGPT, for example, what will be the weather next 1 week, or what is the current weather? It has no idea because whereas on contrary, if you ask how was the weather for Sydney for the last 1 year or 2 year, that it can answer because it was already pre-trained with that publicly available data. But current information or any other information which it was not trained for, it has no idea. So what you can do is you can hook up the GenAI model to call an API. Basically, this is an API, MCP. So you have MCP server, and then the model calls via the API, and then the MCP server basically calls the respective API. So, for imagine this is the weather website API, or it could be any internal API which exposes that information, right? So you can hook all these APIs to the MCP server, and your AI will call your MCP server and get the information. And based on that information, it will make a decision. This is a generalized view, like how AI agents work. So you have an autonomous action, and then so you have this concept called agents in GenAI. So what are agents? Let's say you have a very complicated task, right? So what we saw here is very simple and generic, right? In ChatGPT. This is quite straightforward. You don't really need an agent to do this behind the scenes. But let's say I want to create a website with so and so details and etc. Uh, it involves multiple tasks, right? So, for example, one of the tasks could be to understand the requirement. Another task would be to create the code. Another task would be to compile and run the application, and the other one could be writing unit test, etc., etc. All these things. So your model, one model in one end, behind the scenes, a cluster of servers can't do everything. So what you do is you create multiple agents. So agents are basically specialized for a certain work, like I was mentioning earlier. And what happens is that services like Bedrock or a lot of serverless service in different cloud providers, what they do is they orchestrate all these agents and then produce the necessary output. I'll show you the demo in using a tool called Kiro, but just this is the high level understanding. This is the LLM. These are some of the key concepts of model custom. So every model, like I was mentioning, you can customize because every business use case and requirements are completely different. So there cannot be a general fit for all purpose model. That is technically impossible unless you're querying something like ChatGPT. So in our day-to-day business and in enterprise, in big organization and enterprises, what happens is that 99.99% of the case, you have to customize your model based on your requirements. So this is where RAG, MCP, and all these things come to. On top of that, you can also fine tune a model, right? So what happens to RAG? RAG is an external source of data. You're not changing anything in the model, right? MCP is just a server sitting between your model and your data or API, right? Now, there's also another option called fine-tuning a model. What does that mean is you can take the general model, right? And then you can write algorithms and you can manifest your own data and then retrain the model so that it is more accurate and fine-tune for your use case. You can do that as well. Now, coming to, I think this should be the last or some more topic. Yeah. Okay. Now we have done everything. A lot of questions and confusions. What happens is that is the AI responsible? Can it generate proper content? Is it fair? Is it transparent? Is it secure? A lot of questions, right? Because this whole AI is a man-made system, right? Anything that's man-made, even in we as a human, we are prone to errors. Similarly, AI systems, the computers are prone to errors, prone to failures, uh, prone to accuracy problems. There are a lot of issues. Now, how do we make sure all these AI generated content and whatever outputs it's generated, it's fair. So that's what uh, that whole concept is called responsible AI. So what is responsible AI is how do you deliver AI in a responsible way such that it's fair, it avoids bias, right? So for example, sometimes when it generates content, it shouldn't be very biased or skewed to a particular religion or ethnicity or something like that. And it also should say how transparent it is, like how did it make decisions rather than ad hoc way. And for example, some of the sensitive information cannot be exposed. For let's say your card numbers, you can't expose the card number openly, right? It's not a publicly available information. Uh, and for example, you could have some privacy data like your medical records. No patient would actually expose a medical record. Medical records is private and sensitive, right? So even you can skim through the data and make a decision, but you can't expose that data to the public, or you can't expose that in the content because it's private. It actually violates the privacy law, and everywhere you have this privacy and compliance issues. And how about it generates harmful outputs? How safety it is, and how accountability uh, the human which who oversights the answers and governance it has. So we need to consider everything. So it's not just, you define a system, you train it and then generate the output. There are a lot of compliance and governance and controls in place for as part of the responsible AI. And one of the biggest problem with AI, if you notice, is called hallucination. So what is hallucination is, because the if you ask a lot of questions, or if your prompt is not clear, or if your requirement is too generic or uh, not so clear, what happens is that often when the AI learns something, or when it generates new output, it hallucinates, right? So basically, it gives you wrong answer, or it gives you some answer which is completely different to what you asked for. So that's what is called hallucination. Um, so we have more concepts like toxicity and bias. You can do content filtering, etc. A lot. So I'll demo some examples through AWS, because I'm an AWS expert. I worked on Bedrock, SageMaker, and a lot of these tools. Some of the services which you can use in AWS is, so for example, Bedrock is the serverless model, where serverless service, basically where you can play around with all these models. And SageMaker is something, let's say you want to develop your model from the scratch, your own model, basically, if you don't want to use the publicly available model, and etc. So these are some of the tools, what do you call, tools which already does the job for you. For example, recognition is something, a service where it analyzes and your images and videos. Comprehend, it's basically NLP, the natural language processing. This is example, I could say, in Amazon website, a lot of people write reviews, right? How do you know whether it's positive or negative or neutral or something else? So it's all, it's again behind the scenes. It analyzes the text, it analyzes sentiment, it summarizes, it categorizes, and then produces the necessary output for you. Same with poly or transcript. You can do text to speech, speech to text, and you have extract, where you can extract the text from the documents. For example, we do when you upload a payslip, it extracts that information and then um, uh, leverages and uses sends it as an output to the other systems. Any questions so far?
Hello, sir.
Yes.
There are some questions in chat box, sir, that has been asked by the faculty members.
Yeah.
Please see the chat box, sir.
So Mr. G. Prabhu has asked, can you explain hyperparameter tuning? How do I develop generative AI model? And can you suggest any tools to design a generative application? Yeah, good question. So parameter tuning is basically, so when your model generates the output, right? So you can tune what sort of response you want to get from that output. So for example, I want less bias, I want it to be more generic, or I want it to be less generic, and all those things. So you can actually customize it. So it's not like, so for example, like in ChatGPT, I just prompted something and just it gives an output. You can control what sort of an output you can generate. So that's what is called hyperparameter tuning. I'll show you that in the demo, sir. And how do I develop generative AI model? Good question. So you can do it in two ways. First, you can use a existing foundation model. So AWS has a lot of models. Nova, Anthropic has a lot of existing models like Claude and all those things. And you can extend it and fine tune it. Or if you want to develop from the scratch, you can use SageMaker. So I'm giving you example from AWS, but there are a lot of other tools as well. Now, can you suggest any tools to design generative AI applications? Yes, you have SageMaker, you have Agentic Co in AWS. And okay, next question, Professor R. Prabhahari asks, can you explain about self-supervised learning? Okay, good question. So self-supervised learning is basically a subset of supervised learning, right? What is supervised learning? It has a label data. So a human says, this is apple, this is orange, etc., right? So self-supervised learning is the model learns from labeled data. So the labeled data can be two ways, can be actually performed in two ways. One is through the human, but what happens with the human interventions is that when you have two huge large data set, it's technically impossible for humans to actually label all the data. So self-supervised learning is basically the system, the model itself, when it encounters new data, it labels by itself without human intervention. So that is self-supervised. So that's the message. Next question, explain about semi-supervised learning. Okay, yeah. So semi-supervised learning is basically something like you have human intervention. After a stage of point, the model and the system where the service, basically where the model executes, it learns on its own. So that's semi-supervised. Again, it's based on labeled data. So I'm Revati. Last question, I'm Revati. How RAG and MCP useful for non-competent students? Okay. So this has nothing to do with computer science or non-computer science students. With the RAG and MCP, you can design and generate any content you want. So it has nothing to do. So let's say a non-computer science student want to, it's not necessarily creating a website or any other content, right? It could be anything. Like you want to automate a system. A best example would be like my wife used to work with Honeywell. She wrote the autopilot system, right? So the autopilot system, the entire code which interacts with the machines, actual physical machines, you pretty much can actually generate that code completely with the GenAI model nowadays. So for that, you can use these RAG and MCP servers. You can build anything, any tool and any service you want with RAG and MCP. It has doesn't necessarily have to be related to computer science. Prabhahari, what's the difference, ma'am? What's the difference between traditional program and ML program? Right. So traditionally, what we used to do is, so you have this SDLC process, right? Software development life cycle. So what happens is, the business people, they have a requirement, they fund a project, somebody understands the requirement, they draft use cases, and then the architects perform high level design, low level design, and programmers actually implement through a programming language like Python or Java, etc. And testing, deployment, DevSecOps, it goes on like this, right? So machine learning program is so traditional programming is basically you architect, design, and build the system for a very generic purpose, right? Machine learning program is basically you're trying to do the same you're where you're training the machines and generating the programs. That's the difference. So basically nowadays what you do is that you ask the ML service that this is my requirement and these are my use cases, and it automatically generates the code for you. Or, for example, you say, okay, these are my, this is how you build your code. This is how you generate the artifact. This is how you deploy the code. This is my requirement, basically. And then the ML program, the app, basically, end of the day, it performs the action for you. That's the difference. This is Asma. Why RLHF is important in LLM? Okay, yes. So, good question. So, in reinforcement learning, what usually there's no human intervention. Now, what happens is, even for a very complex use case, you always need a human feedback saying that, say, for example, you need before you do a deployment, say for example, right? Even let's say through the reinforcement learning, the system understands and says, okay, you are ready for deployment. You still need a human to actually approve the workflow to go to the production. So similarly, a lot of times when the system learns, when the model learns through the reinforcement learning, you often need a human feedback to correct its scores. Not every time, based on the reward and the penalties, the reinforcement learning is accurate. So to improve the accuracy and to actually involve human review, you need human feedback, basically, for that system to make it more sharper, right? So that's where RLHF comes into picture. Again, it comes to the problem, solving the problem of accuracy, not having bias, not to hallucinate as much as possible. That's the intent. This is Ma'am Anandi. Can you suggest a few more evaluation metrics rather than patient? Yeah, so there are a lot of evaluation metrics. One such example is BERT score. There is F1 score. There are a lot of evaluation metrics. Which skill set or training required for students to get placement in MNC IT companies? Yeah, good question. So regardless of what GenAI you use, at this moment, you have to know or you have to be hands-on with any cloud provider, AWS, Azure, or GCP. That's the first requirement. And second requirement is how you will actually use GenAI. So basically prompt engineering. So I can mention you. So basically it's any cloud provider, prompt engineering. There is a big field called prompt engineering. it's a field on its own, like how you do research and domain research and development and different sets of fields, right? Even in traditional IT, if you see, you have infra, you have DevSecOps people, you have developers, and all these things. These are all fields. So in Gen AI, there is a specific field called prompt engineering. So there's a huge demand for prompt engineering. The prompt engineering, what I was talking about, is that zero shot and few shot prompting, right? There are a lot of prompt engineering techniques which the market use. And on top of it, how data scientists, because data scientists is basically, they are the ones who create the model or fine tune a model, and and even developers with knowledge of all those RAG, the concepts I was talking, right? RAG, MCP, LangChain, etc. So what's LangChain is basically, this is how this is like a complex task, right? If you notice ChatGPT and many other tools, it can understand the context. So you ask a question, it produces an answer, and then you ask a second question which is very relevant to the first question. So you don't actually prompt in a single way. You do it successfully, right? So you ask the first question, you're not happy with the answer, or you still need refinement or more a better output. Then you ask the second question which is related to the first, and then you go to the third. Again, third is pretty much related to one and two. So that's how behind the scenes how it works is that there are agents, and you use LangChain to basically understand the context of the first request and response, and you chain it to the second prompt. And third prompt is basically from 1 to 2 and 2 to 3. So all those behind the scene concepts you basically develop and implement through LangChain. So that's the answer for skill set or training required for students. This is Satyapriya. Is ChatGPT getting outdated among technical people? So ChatGPT is just a general purpose model. So on top, I mean, I would say it's like your something very similar to Google search, right? Because Google search is very primitive. ChatGPT is like you can ask anything. But other than that, you can't do very complex tasks where enterprises require. So it's just like a very primitive tool for your daily tasks. But you can't actually replace programmers with ChatGPT. That's not possible. Did I answer all of your questions?
Yes, sir. You have answered all our questions. It was a very nice presentation, sir. Is there any suggestions from you to improve prompting with the AI tools?
Can you put it in chat? I can't hear properly. If you can post it in the chat, I'll reply. So this is theory, right? Okay. So prompting, there is a big course in AWS for prompt engineering. You can go through that. And there are a lot of publicly available sources. You can learn through those materials. I don't know. I don't have any specific examples, but you can go through the AWS AI Practitioner certification where it teaches you about all those prompting. And prompting knowledge is more like the more you use, the more you get better with the prompting. Can I go with the demo?
Sure, sir.
Okay. So this is the token thing I was talking about, right? You need to know what are the set of tokens which you need to understand. So one example is, for example, you can use this free website called Party Rock AWS, right? So you can generate an app, very simple, right? So I can ask something like, hey, create me a travel uh, blog, for example. So all these things you see behind the scenes, right? What is happening? It's running the agents and it's invoking a Gen AI service like Bedrock or whatever is it, and it's running. It's using the model, generating the output. Everything is happening behind the scenes, as you can see. So this is not just simple chat GPT question, right? So I have asked something very specific. I want a travel blog. So example is you can see here. This is one of the this is the generated output. So what it does is as you can see here, you can say which destination you want to travel and for what purpose, etc. So this is one of the prompting, right? So I was not specific. I asked a very generic uh, prompt saying that create me a travel blog. So it does not understand the context. So that's why it created a website, something like this, right? And then you share your story, etc. And it'll create the blog post and all these things, right? So now let me be more specific, right? Create, enhance this blog to show up top destinations in the world. Now I'm very specific. I'm not saying just say create a blog. So I'm saying very specific. I want to only show the list of top destinations in the world, right? So now it has updated and applied the change. So if you see here, I've added here something like this. So this is a generic website which you can use from AWS, which is Party Rock. So the other service which I was talking about, right, a lot is Bedrock. So this is a serverless service, basically to play around with all your models. And you can also fine tune, deploy them, and you can do whatever you want. So for example, I'm going to the playground, which is very similar to the ChatGPT or Party Rock. Over here, I select the model. So these are the models I was talking about, right? So for example, Amazon have their own LLM. So these are the LLMs. So each LLM is used for different purpose, right? For example, with Micro, I can only generate a text, but I can't generate an image or a video. On contrary, for Light Pro and Nova 2 Lite, I can generate multiple contents like text, image, and video. Same with OpenAI Anthropic, which is quite famous. We use a lot of this, Claude Sonnet, and all these models used for different purposes. Google they have their own models. Facebook have some of them. All these things, yeah. So I'll give you one example with, let's say, maybe this one. So if you notice here, the whole model, how it works is it cannot work indefinitely, right? It has a boundary. So each of your model can actually has an input limitation. Basically, it can accept only at a given point of time this much of tokens. and can generate only this maximum of certain number of tokens, right? So let's say I'm picking this one, and I'll do a comparison mode also. So if you notice, one other thing, another example I forgot to mention was uh, in this whole AI concept, and especially GenAI, your output is not deterministic. It's called non-deterministic, right? So even if you give the same prompt, the next time when you copy paste exactly the same prompt for the same model, there's no guarantee that you'll get the same output, because there is no fixed rule or some sort of a map, right? So it's all generated dynamically for you. So the model at that time makes decision at that particular instance, which exactly behaves like our human brain. So let me select, say, for example, Anthropic Claude for an example. And let me ask a question. For example, what is AWS? Can you explain me in layman terms? So I don't have access for Anthropic Cloud. Let me select a different model. This is my personal laptop, so I can't demo with the office laptop. So let me select a different one. Let's compare this only with the same between Amazon Light and Nova Micro. Again, behind the scenes, it uses Bedrock. This uses Nova Light model, and this uses Nova Micro model for the same prompt. If you notice, this is the output, your context window basically, uh, which is limited by a certain number of tokens. And similarly, you have Nova Micro. If you notice here, for exactly the same prompt, it's actually giving me a different output. You see here. Then you can also play with tokenizer. So how, if you want to understand how your prompt is actually tokenized and sent to the model, you can, like I was showing in the other website, where you can say, let me type the same prompt. You see here, it has 17 tokens, so it's not word by word, right? So similarly, you have model catalog, where you can browse through the models and then do a comparison. And you can also get marketplace. You can also use models from the marketplace. And then this is the fine tuning, like how you actually create a model from the scratch if you want. And these are the knowledge bases. I was mentioning about RAG, right? So there are some existing knowledge bases. So the RAGs, you can create a knowledge basis through this. So for example, uh, let's say my data is in an S3 bucket, and then you can actually create the knowledge base based on the data which is sitting in my S3. You see here. Uh, yeah. So those are some of the examples. And the other one which I was talking about, let's say you're developing a model from the scratch, and you have to take care of all the data augmentation, cleanup, applying the algorithm, and if you have data scientist and etc., you will use SageMaker Studio to develop a model from the scratch. Right. Now, coming to the last part, which is very interesting and important, is have you heard of this tool called Kiro? AWS Kiro? So this is a new service. I would suggest all your teachers and students to have a look at this. This is very interesting. I would say, I would recommend. So this is my Kiro IDE, similar to your VS Code. You can create everything, whatever you want through this Kiro. So you can build something based on vibe coding and spec coding. I hope you must have heard of this keyword called vibe coding. So what is vibe coding? Basically, traditionally, how would you code is that you manifest and specialize in a programming language, and then you type in those commands in the programming language, you compose a program, compile it, run it, etc. Right? Vibe coding is something like as if you're talking to a human, right? Say, hey, like just like how I prompted in the other websites, as you can see, I'm asking, hey, can you do this? Can you do this? Etc. 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 And then it actually creates it understands the requirements, models it, generates the code, and does everything for you, whatever you ask for. So that's vibe coding. So make it very generic, right? Now, there's another type of build you can do other than vibe coding is the spec coding. So spec coding is basically you say in detail, these are the steps. So I say like, this is how my architecture should look like. This is how my design should look like. This is how my system should look like. And these are how the services and the nodes inside the system should interact with each other, etc. And what is the coding standard? What are my requirements, etc. Right? So in this demo, I would show you how vibe coding works. You'll be shocked how I build some system in a matter of few minutes, right? So I could think of an example for your for our college. Let's say I'm saying something like, "Hey, build me a website for college students who got placed, who got campus, who secured campus placement, uh, campus placement. Now I'll give some little more details because this is too generic. So I'll say list down students name, age, department, the degree, their score, and company, offer, and salary. Also, and on top of that, give me a summary based on department and average salary, right? That's it. That's all I did, right? Enter. So behind the scenes, like I mentioned, all this processing happens. So this is how we code, technically speaking. Nowadays, we seldomly use programming languages. Behind the scenes, we use VS Code and necessary tools, generate the output in whatever language and tooling you want. and then build and then deploy them. That's it. So the effort to build a system has been gradually dramatically decreased. Right in front of you, this is my requirement. I'll show you in less than 5 or 10 minutes how does it actually creates a website quickly for you. If you can see, I didn't intervene on this, right? What it does is, whenever it encounters an error or a problem, it tries to rectify itself, or it tries to implement alternative approaches to fix that problem. Yeah, you see here now there was a problem accessing this folder because it did not have permissions, but now it encountered that error, fixed the error on its own, and then implemented it. Yeah, that's it. There you go. So if I open this in the browser, let me open it. See this? So it gives you a list of students who got placed, their department, degree, score, which company they were placed, salary, including beauty, making it look beautiful, the user experience, and the summary, etc. Over here, including the code ready to be deployed. In this case, it created HTML, but you could customize it whatever you want. And you notice in a matter of minutes, it created the website. This is the new coding era using GenAI. This, this is how we are. This is precisely the way we actually work every day. Imagine traditionally, if somebody would need to create a website, like even if I know it's a single page, they would require a lot of knowledge on CSS, the styling and HTML, etc. You don't really need to know all of this at all anymore. You see how much of code it has generated. This would at least, even for an expert, it would have taken at least an hour to develop. Now it's all a matter of minutes. So I would highly encourage students and staff to use this. And other tool, there's one more tool I would suggest is to use Bedrock, and also learn more about, there's a new service called Agentic Core. So this is where, let's say you have a complex use case where you need to, where you have multiple agents performing different set of tasks, and you need to orchestrate them. Um, you need to scale them. You need to make it, address complex use cases. You can use agentic code. Any questions? That's the demo, by the way. Or if you people have any specific use case, I can demo through Kiro. Once again, any questions, or you want to see something else in through Kiro? Let me know. I'll just do it now.
No, sir.
I think that's all I have. Any other questions? So with regards to which direction you need to go, what to learn, how you can retrain your staff and students, please reach out to me anytime. So we can't learn in one session. GenAI is a very broad topic, to be honest. In this session, what I wanted to, my intent was to give you an idea how it works and what's happening in the industry and how do we work every day. But if you want more sessions in deep, for example, how do you fine tune, customize some of the use cases, etc., I can do it in a different session. But I would recommend people to start learning these technologies and tools. So Kiro is an IDE from AWS, and also learn agentic core. Sure. Yeah. Thank you very much. Yeah. Uh, do you want me to explain vector database or MCP protocol and agents? Okay. So I already talked about MCP protocol and agents. So what is a vector database, right? So if you notice in my PowerPoint, when we talked about especially the RAG, yeah. So with RAG, I was talking about yeah, yeah. So this is your knowledge base. And when you have a RAG, So basically that information, what your proprietary information, what you're exposing it to the model, right, to learn and use that crucial information, we store it in a specialized database called vector database. So some of the example for vector database in AWS is, for example, is OpenSearch. So why vectors? In database, you can store data in a different format, right? For example, you could have uh, a structured way where you have rows and columns, where you have unstructured way, it's stored in a JSON or binary, etc. So when you store your data in a vector, the advantage, that's another format, basically, vector, the mathematical vector I'm talking about. So you have multi dimensions, which means that the same data, it's not just some, usually when you do with rows and columns or non-structured way, you can only have one dimension or few dimensions, right? 2 dimensions or 3 dimension max. But you can't have multiple dimensions. When you store in vector database, you have multi-dimension. Why do you need multi-dimension is normally your AI data, which is trained, and how you actually deep learn via those neurons and multi-layers. If you notice, when you have multi dimensions, you can easily understand the relationships and pattern inside and between the data, and that is why we use vector databases in as embeddings in databases like OpenSearch, which means that your data has more dimensions in terms of it has more semantics and more meaning, basically, rather than just plain certain 1 or 2 dimensional. That's the whole picture, basically. Did I answer all the questions? Okay. Uh, Thanks for giving me this opportunity, and thanks for listening as well. Okay. Thank you. Bye.
Thank you, sir, for your wonderful session. Even though I'm not a faculty of computer science stream, I can able to get basic concepts on GenAI, sir. Thank you,
That's
sir.
good. That's good. Thank you.
Okay. Thank you, sir, for
Yeah,
your
thank you. Bye.
wonderful session. And
All
also,
good.
I like to
Thank you very
thank
much. Bye.
Somasundaram sir, the adjunct professor of computer science, for joining with us. All the faculty members, those who are from various streams, for this wonderful presentation. Thank you, sir.
Good. Thank you.
Can you close the screen and come? உங்க இது மட்டும் ஃபுல்லா வர மாதிரி வச்சுங்க சார். ஒரு ஸ்கிரீன்ஷாட் எடுக்கிறேன் ப்ளீஸ். போட்டோ பிபிடி க்ளோஸ் பண்ணிடுங்க. ஸ்கிரீன் ஷேரிங் க்ளோஸ் பண்ணிடுங்க. நீங்க மட்டும் ஸ்கிரீனுக்கு வாங்க சார்.
ஓகேங்களா?
சார் ஸ்கிரீன் ஷேர் பிபிடி க்ளோஸ் பண்ணிட்டு வாங்க சார். அப்பதான் நீங்க ஃபுல் ஸ்கிரீன் பார்ப்பீங்க.
Sir, good afternoon, sir. The
Good
Zoom
afternoon.
open பண்ணிட்டு அதுல ஸ்டாப் ஸ்கிரீன் ஷேரிங் கொடுக்கணும் சார். அப்பதான் நீங்க ஃபுல் ஸ்கிரீன் வருவீங்க.
Okay. Stop. Right.
Okay, sir, enough.
சார் நீங்க பேசுனீங்களே தவிர சார். சார் நீங்க ஏதோ பேசுனீங்கன்னா ஸ்கிரீன் ஃப்ரண்ட் வந்துருவீங்க.
Mm.
தேங்க்யூ சார்.
Okay. Thank you. இப்போ மீட்டிங் லீவ் பண்ணட்டுமா?
எஸ் சார்.
Okay.
தேங்க்யூ சார்.
Thank you.
போயிட்டே இருக்கும்.